Well, good evening, everybody. This is meteorologist Andrew Pineiro with another episode of Climate Matters. So, this one's going to be, the overall topic is war and weather. So this is something quite interesting, but let me just post out here that we are live. So if anybody's following me, I have a Facebook and a Twitter account, Instagram account. Let me get these all posted out. I'm assuming it's working here. Here we go. So, thank you all for joining me. It's great to be back, and if you happen to be watching from the Northeast US, it feels like summer again. All right, there's the live stream. Let me share this now. Gotta get out on as many platforms as we can. So, not sure if anybody is too familiar with how weather affects war, but it's actually a thing. It's actually happened before in the past. All right, got this one posted out. All right. So, got a couple of articles. I'll show those to you in a little bit. But overall, war is an unfortunate part of humanity, and it's something that's been around for quite a while. And war can't really happen without weather, just because weather is everywhere. So, I guess we'll start off with this first article that I have up, so you can switch now to the computer screen. And essentially, this one, the Harvard Crimson. Weather has an effect on the war. It's interesting because it actually starts off, war does not affect weather, weather does not affect war. That's kind of a mantra that we've seen before with a couple other people. There's the mouse. So war does not affect weather, weather does not affect war. But that's not entirely true, and it just starts, and actually this article goes through all that. So essentially with this is talking about real current war situations. We can switch back to the main camera now. But what's going on there essentially is, say we're taking what's going on in the Middle East. There's a lot of heat out there. Temperatures can be 100, 120, 130 degrees Fahrenheit, which I believe would be around 50 Celsius. Not exactly sure. Let me just do a quick little math check here. So we got 120 Fahrenheit. Yeah. So that's about 50 degrees Celsius for all the international viewers. So that's very hot. And a lot of machines tend to break down with heat. So this is where not just cars and stuff, but weapons. A lot of weapons need to be engineered specifically for that type of climate. So climate has a lot to do with war and equipment. Another thing too are, say, Humvees or any kind of armored personnel carrier. That has to be able to tolerate those high temperatures. So back when we were in the New York International Auto Show, we were kind of all in those car phase, but we'll go into that a little bit because we're seeing these temperatures kind of affect what we would think of for radiators. And with the radiators, they have a certain limit. And with the limit, it has to do a bit more of its thermal capacity. It's getting a little bit sciencey there, but when you have something that has to try and radiate heat outward, if it can't compensate for the heat around it, then you can't really have an effective cooling system. So that's where in cars or in vehicles that are out in the Middle East, Afghanistan, or Iraq and stuff like that, that's where we have to deal a little bit more with special type of weather engineering. And that's something that is where weather can affect the war. That's one thing. Another thing, going back a little bit, Vietnam. I believe it was Vietnam. That was the Ho Chi Minh Trail. So this is something that came up with weather engineering, and that was something I didn't even really know actually happened in weather modification, which actually is a thing. So this has to do with cloud seeding. Not sure if anybody's familiar with cloud seeding, but that is something where we use that in the US. Essentially, you have crops out there and there's no rain. You need to make rain. So there's planes out there that fly over crop fields, and they plant they call them seeds. And when they're planting the seeds, it allows these water particles to kind of attach to what we talked about, not last week, but I believe 2 weeks ago with the water cycle, these nuclei, and that allows that water to really grow. And that's something that's really cool to see. I'm also going to see, let me check one more thing here. Just want to see if I can actually see you guys. Trying to get the screen thing going back up, so we're going to get that fixed. In the meantime, I just want to see if I can see you guys. Let me see. Oh. There you go. Scott. All right. Now, it's interesting if I could actually see the chat myself on here. All right, that works. The Honored, hello, welcome to the chat. All right, so essentially with the different types of vehicles, there's something called a radiator. And a lot of high-powered vehicles, that has to do, not necessarily military vehicles, but vehicles in general, they don't have one radiator, they have multiple radiators, and some have what are called intercoolers. So I have a WRX, and with the WRX, there is essentially 2 radiators, or technically 3. One's the main radiator for the coolant that's in the very front of the engine, and that's what allows the engine itself to stay cool, because essentially there's explosions happening inside engines. So that's the main radiator. Now, with a turbocharger, because this uses a compressor, whenever you take air and compress it, it heats up. This is where we have differences in temperature. So at the surface it's warm, but up in the atmosphere it's a little bit cooler until you get to a certain point, because then as you expand, it cools down. So turbochargers force extra air into the engine, and that creates a lot of heat, and that is where you need something called an intercooler. That's something that mine is called an air-to-air intercooler, where the air from the turbocharger passes through some radiator fins, and cool air flows through those radiator fins, cooling down the air, and then that extra compression gets forced into the engine. So that's essentially how radiators work. Hello, welcome to the chat. Thank you. Thank you guys for welcome to the chat. So it was a weird thing where I was able to get the chat. I can see you on here. So I hope you're good as well, Stinky Fingers. So essentially what we're talking about overall for this episode is weather and war. I'm breaking it down a little bit into different climate zones. So we're talking about Middle East. That's kind of a big thing right now. And in the Middle East, there's high temperatures, so that's where these radiators and intercoolers, because turbocharged diesel engines tend to be in more torque-heavy things, like those big armored personnel carriers and tanks and stuff like that. So you have to have a lot of heat expulsion. So that's a challenge. If you take the same situation and you flip the climate from very warm to very cold, that changes things quite a bit. And changing the climate to cold all of a sudden, if you have something that's designed for heat and you make it go into a cold climate, then it can seize up and different things can happen. That's essentially how winter tires and summer tires differ, just because winter tires, the rubber is designed to be working at, say, 40 Fahrenheit and below, or even below freezing temperatures, below 0 Celsius, below 32 Fahrenheit. If you take that type of tire and you have it on a car, which I'm glad I took mine off now, in 80-degree Fahrenheit weather, which is about 27, 28 Celsius right now, they would start to just fall apart because that rubber is really designed to be colder. So adjusting the equipment for the different climate has a lot of or a big effect on things. That's an interesting question that you have. So, visited by another race, or aliens, for instance. That's kind of a possibility from what I'm thinking, but with war, I don't think we would want to go to war with alien species or anything like that. So, maybe we have in the past. I hope we don't in the future, just because that's something that can have universal effects without giving anything too much away about certain things happening in movies right now. But if that was a thing where we were actually visited by an alien race in the past, maybe they saw we had lots of war out there. But also, maybe it was maybe they're out there right now. Maybe they're watching this live stream right now. You never know. So that's kind of an interesting thought. Anyway, back to the vehicles. So vehicles have to adapt to the climate that they're in. And assuming, this is what I'm saying as a scientist, climate change is a thing, vehicles would need to adapt as well, or equipment as well, or just anything that you use with war. Ships, vehicles, weapons, aircraft, all of that you have to adapt. That's also why some airplanes can fly very high into the atmosphere where it's like negative 40 degrees out there, and some airplanes just can't handle that. The one I'm specifically thinking of is the U-2 spy plane. That has been thought of as the most difficult plane to actually fly. And if anybody watches Mythbusters, I love the original Mythbusters with Adam and Jamie. I haven't really watched too much with this new one. But there was an episode where Adam flew with or on a U-2 spy plane. And it's very difficult because there's really only one wheel in the middle and one wheel in the back. So it's very unstable. But you have to have these planes adapt to the climate that they're in. And if we take a climate that's very high in the atmosphere, almost, and when we talked about the layers a couple of weeks ago, let me see if I can bring that picture back up. Let me see. It was basically layers of the atmosphere. And it showed all of these. Here's the picture. And I'm just going to see if I can get this over here. There's the picture. All right, we could switch to the computer monitor screen. So, if you remember, not too long ago, I had this picture up. And this shows every layer of the atmosphere. The orange layer here, this is the troposphere, the very bottom layer of the atmosphere where we live. Then the white layer here, this is the stratosphere. Then the blue layer is the mesosphere. And then that black area up here, this is the thermosphere. So with this troposphere, as you increase with height, you drop the temperature. So let's say right here where the mouse is there, that's right at the surface, for instance. As you increase height, you're decreasing temperature. Then, when you hit what's right here, this is called the tropopause. The tropopause switches from the troposphere to the stratosphere. Now, this is typically the layer where airplanes are. And in here, as you increase height, you're increasing temperature. Opposite happens once you hit the stratopause, which is between the stratosphere and the mesosphere. But essentially, this airplane was at the height of the stratosphere, and I believe it even went into the mesosphere, not all the way out into the thermosphere, but it was in this blue layer here, which was called the mesosphere again. Now, the space shuttle, this is specifically the Space Shuttle Endeavour. The Endeavour essentially is floating right out into the thermosphere, which is right about out here. Really high, that's where the aurora borealis or the northern lights are, so that tends to be right out here. All right, so we could switch back to that main camera. And with these different layers, you have different, essentially, climates or microclimates with different temperature profiles. So that U-2 spy plane, that has to deal with super cold temperatures, almost on the brink of space. And with these really cold temperatures, not every plane can deal with that. So that's where we really are adapting our war equipment to different climates. Also, going back into history, this is where meteorologists like myself had a really big effect. So now we talked about kind of vehicles and different equipment stuff. We're going to go back in time now. We're going all the way back to D-Day. And on D-Day, it almost didn't happen. And if timing was off, D-Day would have actually killed tens of thousands of troops landing on Normandy Beach. So, what happened? Well, there was a pretty bad storm happening. And the Germans, or the Nazis, their meteorologists were saying it's way too dangerous. The Allied forces are not going to be actually sending troops over. We could kind of ease up on our guard. However, the Allied meteorologists, so the US meteorologists, British meteorologists, and a couple others, they actually saw a 3-hour window where the weather kind of calmed down a little bit. So they're reporting that to the generals, and they're saying there is a time where we can attack, and it's going to be this specific time. If it's too early or too late, then the troops on those I forgot what they were called, but the boats that were carrying the troops, those troops would probably die because those boats wouldn't be able to survive the harsh weather, which I believe was some sort of a hurricane, but that I'm not exactly sure. I just want to double check on here real quick. I just want to see what type of weather was going on there. Basically, I'm just looking up D-Day weather. And the weather on that day, let's see. I don't know if it says it's going to be a hurricane or if it was just some really bad coastal storm. Just double checking right now. So June 4th, the bright morning to the dawn on June 4th, 1944. Looks like. Just thinking of what kind of weather. Let me see if I can find if it's a hurricane or no. All it says it was stormy weather. And they don't actually have a picture of the storm, well, it was quite interesting. So essentially, this little bit of a window allowed the attack on Normandy Beach to happen. So if the meteorologists were wrong, that's where those troops actually would have basically drowned in the water, because those boats would have been either turned or capsized, or they would have actually just sank. So that was one of the earliest things I learned personally of how the war or weather was affecting a war. There's a couple ways we can look at this too throughout the stream here, but we're going to look at it as weather affecting a war and how war is affecting weather, kind of going back to that original article. So Normandy Beach was an example of that. And it was quite interesting that if those meteorologists, because I know personally how difficult it can be to forecast weather. So if they actually got this very precise 3-hour window wrong, especially in the 1940s when weather forecasting was not like today. You didn't have satellites, you didn't have radar, or radar like it is today. You didn't have any of that. So the fact that they were able to get that 3-hour window right was really amazing. And that allowed the D-Day invasion to happen. So that was one example. Another one, as I alluded to a little bit earlier, was in Vietnam with the Ho Chi Minh Trail. So I don't know the exact thinking behind the whole thing. However, The scientific part was with the cloud seeding. That's where I was talking about crops. Crops need water, and if it doesn't rain, then you need to make the rain with those. That's where I brought up the picture of the layers of the atmosphere as well. But we need water for those crops, and cloud seeding happens by injecting chemicals into the atmosphere that kind of collect water droplets or into actual raindrops, and that makes it rain. They did that, the cloud seeding, over the Ho Chi Minh Trail in order to flood out the Ho Chi Minh Trail. So that is an example of weather modification. And weather modification is something that I never really learned in college. It was after college that I was really learning a bit more about weather modification. So the whole idea looked like, and this is, I'm not exactly sure because history with just general war history is not my strong suit, but it looked like the idea was to flood out the Ho Chi Minh Trail, and that would kind of force the Viet Cong out. I don't know if it worked or not, but the cloud seeding worked, and it really flooded out those areas. This is also where what we do in war can affect climate, not just there, but it's affecting climate change now even. So the other thing I know, because my uncle, was in the Vietnam War. There's something that he's dealing with now called Agent Orange, where they were spreading this Agent Orange throughout the forests or the jungle there. And the Agent Orange is affecting, I believe, his nerves now, or nervous system, which is many, many years later. So that also affected those trees with the Agent Orange, the deforestation. The other thing they were doing was just flamethrowers and kind of shooting the flamethrowers around, kind of trying to burn everything. Because the idea there was if we can get rid of the jungle, there's no place to hide. That was a horrible idea because we need jungles. We need these deep tree areas. And the fact that we got rid of whole forests or whole jungles means that, going back to the cycles that we talked about a couple weeks ago, CO2 levels were probably on the increase because of twofold. Trees were burned down and just destroyed, so there was no CO2 carbon dioxide filter. The other thing too is these flamethrowers that they were using everywhere. Fire puts out a lot of carbon dioxide. It burns oxygen and basically puts out carbon dioxide. So it removes oxygen out of the atmosphere. That's also why miners, not cryptocurrency miners, actual miners and deep in the ground type of mines, but that's why those, if there's a fire in a mine, it may only be minutes until the oxygen is actually depleted because the fire is vigorous and eats up a lot of oxygen in the atmosphere. Thus, those miners in the ground suffocate if they don't get to them in time. So that was kind of the idea with these deforestation and in Vietnam, because if we get rid of these forests, you don't have as much CO2 filtration. And if you're burning everything down, you're increasing the amount of CO2, decreasing the amount of oxygen. So that's where we are negatively affecting the balance of the atmosphere. So those that actually say, no, humans didn't affect anything, scientifically, that's just the facts. You can't deny that we were burning down and the deforestation with Vietnam. That is just something that you just can't deny. It happened. So getting rid of whole jungles is a bad thing. And that was happening. So that's a negative side of how weather and war and climate kind of intertangled, or however you want to say that. But basically, it's a bad thing that happened. Now, also around that time, let me get the exact years. I just want to make sure I get the years right for you. And I know that it was technically not a war. There's technically no Vietnam War. It was Vietnam conflict. But let me just see. I want to get the years for you guys. You see, 1955 to 1975. Okay. So now getting into the late 70s time period, that is the start of the muscle car era, pretty much. Muscle car era, maybe 60s, 70s, and 80s. That was pretty bad for the atmosphere as well. Even though muscle cars are great, they polluted a lot. Because the idea there was not to make the engine more efficient, it was just to shove as much gasoline as you can into the engine to make the biggest explosion. That's maybe not the best, because the more gasoline you're burning, the more CO2 that is produced by the car, which has kind of an effect on the whole atmosphere. Now, at those, the really big block engines, they were what's called a carburetor. Fuel injection means each cylinder, say we got a cylinder here. That's where the cylinder's going up and down. You have a little piece here called a fuel injector that actually squirts fuel into the piston area, into the combustion chamber. That's how most cars work today. Back then, in the muscle car generation, they had something called a carburetor. Essentially, it sat on top of the engine, and it was just a tube of gasoline connected to the fuel pump in the gas tank that was just spraying like just whole drops of gasoline down, and it would be sucked in by the vacuum created by the pistons. That wasn't the most efficient, or the most efficient way to make the explosion, but it was a way to get a lot of gasoline into the engine very quickly. And there are still cars that are carbureted because there's a specific type of feel that a carbureted engine has that a fuel-injected engine doesn't. The fuel injectors have another neat thing with them where it's called atomization. It's almost like you have we don't have a bottle here, but a spray bottle. When you're squeezing the trigger, it's spraying a little mist. That's essentially what it looks like with the fuel injectors. It's spraying a little mist of gasoline. So that's more fuel efficient. Back in those days where we're in the late 60s, 70s, and the 80s, that wasn't the thing. I just want to make as much power, shove as much gasoline as I can into those engines. So CO2 spiked because of that in those couple of decades. Also, in the 60s to the, what is this, mid-70s, 1975 was it? Yeah, 75. To the mid-70s, that's also where, even though it wasn't over major continents, or I should say the mainland US where I am, but it was, let me see, ooh, I lost the page, there's the page. It created extra CO2 that we didn't need. And the forests just weren't there. Now they are growing back, but talking about time periods, the time period it takes a whole jungle to grow back is lifetimes, human lifetimes. So it'll take generations to regrow that. So that's another big challenge with climate change and people saying climate change just doesn't exist, is because you're not looking at the scale that you need. If you're only looking at, say, today, for instance, we hit, what's the time? It's 87 degrees Fahrenheit right now, which 87 Fahrenheit going to Celsius for all those international is 30 degrees Celsius. So it's 30 Celsius out right now, which is unusual. It's not supposed to be like that in the area that I'm in. It's only supposed to be in the 60s, which is about, say, 18 to 20 degrees Celsius. That's where it's supposed to be right now. It's way above that. Can you say this is climate change? No. Can you say this is not climate change? No. We need to look at time scales. The bigger the time scale, the better the amount of data that you have, the better you can actually talk about climate change. So that's something that we have to take a look at, which is kind of where everything's going on right now. From the Vietnam War era to now, that's kind of the beginning of the time period, or the scale of the time period that we need. Bigger time periods would be better, but that also goes into our human patterns have changed. Excuse me, 100 years ago, we didn't have streaming, we didn't have technology. The Industrial Revolution was very coal and steam powered. We don't really use steam power anymore. They did a lot back then. So our habits change. And with the changing of our habits, that has to do with the climate changing as well. So that's really the only question that I will allow, essentially, to be asked is, are humans affecting climate change? Climate change is happening. It's always happened. Are we affecting it? And from the research that I've conducted, yes, it is. Now with war, not just on the climate itself, but on the strain that humans feel from war, that's something that's really negative as well. So if we're taking a look now, jumping up a couple generations from the Vietnam War, we're going into the Desert Storm. And that year, let me just double check what year that was. Desert Storm. Because I believe I have a couple uncles that were in Desert Storm. I'm not exactly sure. Gulf War. I don't know if it shows exactly this, but basically it was 1991, January 17th to February 28th, 1991. That was Operation Desert Storm. So that was one that I was going to take a look at with this just because that's where we really started to shift our, even though it has happened before, from what I remember, that was kind of what we shifted towards with the Middle East. Now, that has to do with changing also the artillery and the types of weapons we use. And I come from a military family. My dad, he went through a couple of different types of training. He went through desert training. He went through jungle training. There was one that they were supposed to do cold or Arctic training, where they were actually flying out to Alaska. He didn't get to go through that, but you have to prepare and change your equipment based on these different climates. That's kind of the whole idea I'm saying with this part of the show. So in here, if you have a tank with tracks that are designed for ice, may not work as well in the sand. It's kind of neat if you ever watch the Grand Tour. I know I talk about the Grand Tour. I enjoy that show. Even one of my friends that's not really a car guy, he said he watched a couple episodes and thought it was funny. There's one episode where they have a vehicle that's called the Ripsaw. It's a street legal tank that has rubber tracks, like a tire. Basically the law in Dubai where they filmed was as long as it doesn't damage the road, it's street legal. So they needed to change the tracks from steel, essentially, which you would use on some tanks, to this rubber to be a little bit softer on the road so it doesn't actually damage the asphalt. And if you take this type of vehicle and change it to different climates, the rubber may not react as well. Just like the snow tires versus the winter tires, it may not work too well. So even though this is a great vehicle, this Ripsaw, it won't always work everywhere. Maybe if you take this Ripsaw to the Arctic, it may not work on ice. Even though rubber is pretty good, this type of rubber may have started hardening up too much and it may have started cracking on ice. So that's where adapting the equipment to the different climates has a lot to deal with it. So that's something quite interesting that I always thought. But another thing that is also related to war is weaponizing weather. So we talked about that with the cloud seeding, which actually happened. Now, there's a pretty wild conspiracy theory out there. Hurricane Katrina. Hurricane Katrina was a very devastating hurricane that struck New Orleans in the Gulf of Mexico, or Gulf of Mexico in the US. That, you would think, okay, hurricanes naturally go through there. But there was a weird thing with the track, and a lot of people are saying that was actually the Chinese engineering the Hurricane Katrina to strike the US. From a couple of different standpoints, it doesn't make sense. Financial. A lot of warmongers are driven financially. I don't know if anybody plays video games. I love playing video games. There was one, it was Metal Gear Solid 4, I believe. It really went into this. Metal Gear Solid 4. Just want to see if that's the right one, that they were also in the Middle East. Yes, this is the right one. So Metal Gear Solid 4. So with Metal Gear Solid 4, they were in the Middle East, but they were adapting a lot of their technologies to the environment there. Old Snake was kind of a bit of a, I guess, a letdown, kind of. I'd say what you want about the video game, but it was still a fun game. And that's kind of how I think where we're going to go to, is this very technology-oriented warfield. And in there, they had nanomachines that essentially were able to take a look at your body and make sure that the soldiers are healthy. There were also some weird things that they called gecko, which almost looked like, I don't want to get this wrong for the Star Wars people, AT-ST. I think that's the walker, or the smaller one. Yes, the AT-ST almost looked like these gecko. So I have a picture there. Let me see if I can get a picture for you guys of MGS4 gecko. Here we go, gecko. All right, let me just switch this to here. All right, so then I can switch to the computer monitor. And here, Star Wars fans, there is your AT-ST, All-Terrain Scout Transport. So that was from Star Wars. The other one, MGS4 Gecko. Very similar, huh? Same kind of look. They are distinct enough where you can identify that those are from Metal Gear and the AT-ST is from Star Wars. But they have the same kind of basic idea. We can switch back to the main camera. So we're kind of going towards this. We're really starting to change vehicles, which those are vehicles, to the area. We humans are called bipedals. We walk on two legs. Is that advantageous? Yes. We can climb over things. That's where the AT-ST, even though the Ewoks were able to topple them over, using those two-legged machines, or even like the Gecko, those can kind of maneuver over uneven terrain more easily than a wheeled vehicle or a tracked vehicle. So climate, with temperature changing, has to adapt as well. Like we adapt those vehicles to the ground, we also have to adapt our vehicles to changing climates. And if the climate does keep getting warmer, I mean, I'm enjoying this 80-degree weather, but it may not be the best for the environment. We would have to change our vehicles to match that. The other kind of weird thing, and this actually sounds like it's from a movie or a television show. It's a little bit going into, I guess, parameteorology, kind of this metaphysics that we can go into. It's something called electronic fog. Electronic fog is kind of what people believe happens in the Bermuda Triangle. So there is kind of this metaphysical climate that we can talk about in the Bermuda Triangle. And this electronic fog, essentially it's just regular fog, but it's electrified. And that was kind of the reports of ships and airplanes going through the Bermuda Triangle as their gauges and everything went all haywire. And electronic fog, this very high energy static electricity that you're flying through or boating through, can have an effect on that. Another weird thing, just side note with the Bermuda Triangle, it has to do with methane. Methane is a greenhouse gas, and that is coming up from the deep ocean. Methane is less dense than air, so it wants to rise. even air that rising through the ocean, it doesn't rise as fast as methane does. That's kind of another thought of how ships are actually sinking in the Bermuda Triangle, is because this methane that's coming up is going up so fast that it actually pushes, almost like a mini explosion. It pushes these boats up, and it makes that area of the water, because it's all methane bubbles, less dense. And when the water drops in density, the boats sink. So that's a weird thing. But electronic fog is another weird thing in the Bermuda Triangle, and that's something that weaponizing is kind of a possibility. So this one, let me see if before we put it up, I just want to double check if I can find this article again. It had to do with actually making robotic fog, which is kind of a weird thing to say. No, it wasn't that. I don't know if I brought it up. Yeah, so I didn't bring it up, so I'll just talk about it. I forgot exactly where it came from, but nanomachines that we talked about. They're you can't see them. Nano, very small, smaller than the eye can see, but you take these nanomachines and you essentially use that for cloud seeding. Now, cloud seeding we talked about as having nuclei. Oop, where did my computer go? I put it to sleep by accident. There we go. All right, so nanomachines. I'm not going to give anything away either for Infinity War, but they played a part in there. And nanomachines are a real thing. You can have nanomachines theoretically build stuff as well. Now, cloud seeding and nanomachines, you would think, how are they related? So with the nanomachines, they essentially act as the nuclei that we talked about in the water cycle. You have this dust particle or a bug that these tiny little water droplets stick to. Well, if you replace the bug or the piece of dust with these nanomachines that you kind of just inject into the atmosphere, it'll make a cloud of machines, a cloud of nanomachines. This article I thought was really freaky. And this cloud of nanomachines is theoretically possible. And essentially, you can have this be as big as you want because clouds are massive. Having a cloud of nanomachines means that you can actually control the cloud. And when you're controlling the cloud, you can kind of control weather a little bit. That's something that kind of freaked me out when I first read about it. Controlling weather with these nanomachines was kind of freaky and almost sounded sci-fi, but as somebody once said, science fiction is only science fiction before it turns into science fact. So it's a possibility that is out there. So essentially with this, electronic fog, nanomachine fog, if you have fog that can blind the enemy, that could be one thing. Also, you can make it rain over the enemy. We're going back way into like Revolutionary War, U.S. Revolutionary War, where you actually line up, you have a line of soldiers there, and they just shoot each other. If one of those groups of soldiers or those lines can't see the other, you have a pretty good advantage being the side that you can see them. That's something that could happen with these nanomachines. I don't know how far along, because the governments of all nations have quite a bit of secrets. So it's a possibility that could be out there now. It may not be. But nanomachines making fog and making weather, you can even scale that up a little bit. Once you have a cloud that you can control, what makes a thunderstorm? Well, you have clouds, you also have differences in temperature. What heats up one area over the other? Say we have ground that's all very even temperature, nothing's going to happen. But one is very clear, and you have the sun hitting down on there. It's going to heat it up. The other has clouds over it. It's going to stay cooler. Makes sense so far. Now the heat is going to want to rise and expand. When you have this rising and expanding, it's going to want to push other areas around, and that's going to push that cooler, denser air over here into the warmer area, and then that's going to warm up that air, which is going to make it rise, and you have this cycle. That cycle is called convection. It doesn't just happen in weather. We also have that happening in our ovens, at home, in the kitchen. In the oven, you have maybe flame at the bottom. I have a gas burning oven, creates flame down there. It's cool at the top, heat rises, it cools down up there, and then the cooler, denser air falls back down. That's the convection oven. So that happens in the oven, it happens out in the atmosphere. That is a natural process, but it's a process that if theoretically these nanomachines that make clouds actually happen, we can control convection. That may be like, oh cool, you can make a thunderstorm. But thunderstorms lead to a lot of things. Thunderstorms are the core of hurricanes. Thunderstorms can produce tornadoes. Those are the deadly parts. And also there's the rain from a thunderstorm. If you have enough rain, you can have lots of flooding and mudslides. So if we say we make a thunderstorm actually happen, you make it intense enough, it starts spinning by itself, and you have essentially these winds coming in. So you're going to have the convection happening this way. Then, say you have a draft come in from another wind, and this wind is spinning this way, this wind is spinning this way. This is going to want to be pulled up by the convection. When you're pulling the convection up, you're actually turning it. And then you have this type of motion. When you have that motion, that's what produces a tornado. That's where you see, it's called a wall cloud. It's essentially dark clouds, and you see this wall cloud dropping down. A lot of my friends actually do this, and I want to see if I can pull a picture up. Wall cloud. So this would be a great example of a wall cloud. Let me just drag that over. All right, you can put up the computer screen. So that's a wall cloud. You have this dark base of a cloud, and then you can even see a little bit of spinning in the atmosphere there. And this is dropping down. So if this continues to intensify, you may get a tornado coming through out of here. So if we have these thunderstorms being created by these nanomachines, and it starts dropping tornadoes, you can weaponize tornadoes. Let's switch back to the main camera now. But weaponizing tornadoes, that means we can create or have tornadoes form in places they typically don't. Now, rule of thumb, tornadoes can happen anywhere, anywhere on Earth. There's no place a tornado technically can't happen. There are places that tornadoes haven't happened. That doesn't mean they can't. So if we can engineer thunderstorms to happen in places that they typically don't, then we can weaponize a thunderstorm and weaponize a tornado. Now, weaponizing the tornado could lead to, even grander scale, a hurricane. Because every single hurricane out there, every hurricane has tornadoes. You may not think of it that way because you're thinking of the grand scale hurricane, but every hurricane in there has little tornadoes, because these little, they're called kind of like eddies in a river. Those little eddies in the river that flow with the river are our tornadoes when we transfer that scale kind of to a hurricane. You have a big hurricane, you have a flow going around the hurricane, and then you have these little eddies that happen. Those little eddies are sprouting out tornadoes. So if we accumulate all of these these thunderstorms together, that's naturally how hurricanes are forming. And we talked about that last week, and I forgot exactly who put that in the show, in the comments. But that was, I forgot exactly where it was, but it was coming off the east coast of Africa, or the west coast of Africa, traveling through the Caribbean region. It picks up some moisture. It's very moist, high dew points in the Caribbean, creates a lot of convection. And then those thunderstorms, those little lines of thunderstorms, can start conglomerating essentially. And as they start sticking together, they create little vortices, then they can get bigger, and then essentially you have thunderstorms becoming a tropical wave. Tropical waves turn into tropical depression, turn into a tropical storm, and then a hurricane. So it's very grand, and we probably don't have the resources to make nanomachines big enough or a grand scale enough of nanomachines to make a hurricane. But from these experiments that I was reading about, it's technically possible. And I don't know if that's something that kind of freaks me out as a meteorologist, but yeah, you're going to have little nanomachines flying around. Now, I think that happened, oh yeah, that was in Spider-Man Homecoming. In Spider-Man Homecoming, there was, I think it was his chest piece or on his back of that uniform, there was a little bug, spider, that was flying around. That's kind of what we would look at with what nanomachines are, just on a much smaller scale, thus nano. If we have a lot of those flying around, you can also have swarms, like bees, and maybe even you could have these swarms of nanomachines affecting actual wildlife, maybe affecting actual bees, and then we can have bees attacking the enemy. I'm personally allergic to bee stings, kind of moderate, I'd say mild to moderate, nothing really too severe, but a bee sting's still a bee sting, it's still painful. And if we can weaponize bees from this nanomachines, that's something that's kind of weird out there. Now, another kind of interesting thing with tying all this together, we have these nanomachines that are creating clouds, and then you need the convection part. Convection kind of naturally happens, but what if we want to induce convection? There is a program out there, and I just want to get this up. I don't know if I have it here. Let me get the page up. Something called HAARP, not ARP, not AARP. HAARP. Here we go. Now this is actually a thing when I'll show you guys in a second. All right, we can switch now to the computer monitor. So, HAARP. These two kind of go, I guess the F kind of goes away when you look at HAARP, but High Frequency Active Auroral Research Program. Now this has very noble intentions, but as we know from movies, so anything that has kind of noble intentions doesn't always stay noble. Now this is actually a facility, and here's a picture of it. So this is an array of basically satellite antennas, or just antennas. And this array of antennas can shoot radio waves up into the atmosphere. And you can kind of aim these. And as you're aiming these different radio waves, it can heat up different parts of the atmosphere. Here's another neat picture of these radio towers. I wouldn't want to be standing anywhere near this while the thing's on, because putting that much radiation through you is probably not the best. They have this whole project overview and the research thing. I just want to see. I don't think they have the conspiracy part on this. Oh yeah, conspiracy theories. So yeah, if you just want to look this up, it's HAARP, and you can always see all these little conspiracy theories that are around. There's even one from a Stanford University professor, Amran Inan, I guess. Oh, a popular science article. So it's very interesting there. And going up, I'll show you guys back to the top. High Frequency Active Auroral Research Program. All right, we can switch back to the main camera. And the noble intentions with this HAARP program were really just to research thus the name, Aurora Borealis, which is in Alaska, so the Aurora Borealis is the northern lights. I forgot what the southern lights is called. Let me just see. Aurora Borealis, no. That's the northern lights. I wonder if this will show. Here we go. Or southern lights, aurora australis. Because Australia is the furthest, I guess, living place that people typically live before you get to Antarctica. That's the furthest south before you get to that icy, cold continent of Antarctica. Which, yes, there are research scientists that do live out there. But it's something that's not natural, I guess you would say. So, the aurora borealis, or the aurora australis, I think it was called, it's really fascinating. And if anybody's actually seen these northern lights or the southern lights, you know what I'm talking about. Just to see out in the atmosphere, at the pitch black night, these like dancing green orbs and purple orbs out there. You would think you're on something, but no, it's just natural. And there's very scientific reason as to why, which we talked about before with the different layers of the atmosphere. And the magnetosphere, I kind of called it, the deflector shield of the Earth. As you have the sun's solar wind coming in, and these very highly energized charged particles, you have that going around, hitting the Earth, and then the magnetic shield, or the deflector shield of the Earth, kind of spreads them around. And as they're spreading around, they're also going up and into the poles. That's where you see this ring of northern lights in the North Pole and the South Pole. That's the solar wind actually interacting with our deflector shield, which is really cool. And the noble intentions of this HARP program were to research that and to kind of find out, okay, what are the little nitty-gritty details of it? Theoretically, this HARP program and those satellites, or those antennas, can be directed into different parts of the atmosphere to heat it up. A microwave. Like a microwave oven, we're microwaving the atmosphere. And if you really send a direct beam into certain parts of the atmosphere, it can heat it up. And when you heat up different parts of the atmosphere, it makes that less dense, thus allowing things to come in around it. And that's kind of going into steering the atmosphere. When you're steering the atmosphere, you're controlling global scale things. Yeah, those nanomachines, you can make a cloud and you can make a thunderstorm. That's not global scale. A thunderstorm is what's called mesoscale, which is my favorite scale of meteorology. Mesoscale thunderstorms, which essentially is about 100 kilometers. 100 square kilometer area, that's a mesoscale. And yeah, you can technically, theoretically do that, but trying to get that to this global scale is a lot. HARP can do that. And I've had, not too long ago, it was probably a couple months ago, actually, a friend texted me, and she just found out about this HARP and was like, "You're a weatherman. Can this actually happen?" And then my answer was to her, what I'm about to tell you is, yes, theoretically, the technology is out there that we can start microwave oven, the atmosphere, different parts of the atmosphere to heat it up. And that's kind of going into that conspiracy theory of the Chinese controlling the path or the track of Hurricane Katrina. If they have, I don't even know if China has their own version of this HARP array, but if they do, that means they could have shot these microwave beams to one area of the atmosphere, creating a warm spot, and that would allow the flow, once you get really less or low density area, it wants to try and expand outward, and then you have other areas trying to fill in below it, because Mother Nature loves everywhere equilibrium, loves balance of the force. That's actually a thing. Mother Nature loves balance, always loves to have equal everywhere. That's why, an example you can always take, you have a glass of water, you take some table salt, pour the salt in there, and they're going to be separated at first. But then over time, or even as you stir it up, the salt will dissolve and evenly disperse itself throughout the water. That's a natural thing. there is a way to reverse that reaction. You need to basically dissolve or distill the water away, and you're heating it up, and it's turning the water into vapor, and you're vaporizing the water, and as it starts to shrink down, you'll be left with the rock salt again. Now, that requires energy. Those are the two different types of reactions. One type of reaction is just kind of passive, it just happens. Another one, you need to actively put energy into there. I'm making you hungry there? I had Chinese food not too long ago. I love the Szechuan. That's kind of my favorite type of wonton food. But, I mean, yeah, it is dinner time. But, welcome. And, what was I saying? Oh, yeah. So, Mother Nature loves equilibrium everywhere. So, even in the atmosphere, this happens. You have heat, area that's heated up, less dense. Then it tries to pull in air around it to compensate for that density. Last week, we talked about movies. And there was one movie that I liked the way it started out, but then I didn't like the way it ended. That movie specifically was The Day After Tomorrow. That movie started out by saying, storms persist until the imbalance that created them is corrected. So, thunderstorm happens. You have a lot of heat coming down into this one area. That heat rises and then hits the cooler air that falls down because it's less dense, and this convection starts. Once you cut the energy source, the sun sets. As the sun sets, you lose that heat. When that happens, then you're not getting that temperature difference anymore, and it starts to cool down the surface. Once it gets cool enough, convection just stops, cuts off, and then the thunderstorm just slowly dissipates. So that's where that line is kind of accurate. Storms persist until the imbalance that created them is corrected. Hurricanes. You have a lot of hot air coming off the west coast of Africa. Mother Nature doesn't like to have one area of a lot of hot air, so it wants to dissipate the heat. As it travels over the Caribbean, it's not just hot anymore, it's hot and humid. And that extra humidity causes the convection to happen. The convection allows that hot air at the surface to go up to the upper layers of the atmosphere, or the upper troposphere, cools down, falls back down. And that is the cycle. That's why, and a meteorologist that I work with, his name's Joe Rayo, he was talking about how the lot of hurricanes that we had, and deadly, devastating hurricanes we had at the end of last hurricane season, that is a natural process. We do kind of see this uptick of hurricanes at the end of the summer going into the fall, because that's Mother Nature's way of dissipating the heat of summer out. And to do that, it needs hurricanes. So that's why we see that uptick of, say, late August going through September. That transition of we're leaving summer and we're going into fall. It wants to dissipate the heat out. Get rid of it. That's natural. So the process of a lot of hurricanes happening at that peak time is natural. The strength of those hurricanes, no, that's not natural. Hurricane Irma was the strongest Atlantic hurricane ever. It was like 180 something miles an hour. It's not the strongest hurricane ever, but it was the strongest ever in the Atlantic Ocean. Now, that kind of throws out some red flags for climate change. If we are seeing these devastating storms happening season after season, we cannot ignore that. And those scientists that say, all the evidence isn't in yet. It is. All the evidence is in. So, following last year's hurricane season, we'll have to see what this hurricane season is. It's still too early for me to say anything for sure, but things aren't looking as bad. We'll see. That has to do with these global scale things with climate, which are a natural process, but we as humans are aggravating these natural processes. I'm talking about El Nino and La Nina. El Nino we were in the past couple of, and even this has to do with the winters. The winter of 2016 to 2017, we were in El Nino. And El Nino kind of lasted through the summer of 2017, going into that hurricane season. 2015 to 2016, we were also in an El Nino, which is why it wasn't that bad of those winters. There was like one big snowstorm and then little spurts. But this year, we weren't in El Nino or La Nina. We were in a neutral phase, a transition out of El Nino into La Nina. And Spanish names, yes. But that transition now into neutral meant we had a bit more of an average winter. And we saw storm after storm. We had 4 nor'easters in the course of 3 weeks. That is unusual. That's something where we could kind of scratch our heads and be like, okay, I haven't really seen 4 nor'easters happen in a month. 1 nor'easter a week, kind of like that. It was essentially 4 nor'easters in 3 weeks because we had 2 nor'easters in 1 week, which was, it was like it happened on a weekend and then it happened on the Friday. Weird. There's things happening out there that we don't know why. I'm thinking it's climate change. It's us affecting the climate. Maybe it has to do with war. War, weapons, that has all fuel. So getting into nitty gritty, all right, so I have a pistol. I just shoot 1 bullet. There's an explosion that happens. The firing pin hits a little primer on the back. That's that, if you look at bullets, that's that little circle on the back of it, which ignites the gunpowder. Any kind of fire creates carbon dioxide. So if we are ramping up war, I hope not, depending on what leader you ask or what walrus-looking person you ask. But if we are ramping up war out there, we are shooting more bullets. We're shooting more missiles. We're using more tanks. We're using all this more. Using more of all this creates more CO2. We're not doing that deforestation thing anymore that we did in Vietnam, which was, I don't know why they even thought of that. Oh, if we'll just kill the whole forest, get rid of the whole forest, and then there's no place to hide. That was a weird and just horrendous thing to do. We're not doing that anymore. There are actually laws out there that prevent that with the United Nations, which is great, but we have to now kind of cut back. We have to cut back on the war. We have to cut back on everything like that. Even though, yeah, I have guns. It's fun. It's a hobby. Go out, go shooting with a friend, maybe skeet shooting. That's something that's really fun, but that doesn't use as much ammunition as a war does. So if we can try and cut back on the war, we'll also cut back on the carbon dioxide. Not just on ammunition, but also on the vehicles being used. And if we cut back on the vehicles being used, and that could be tanks, that could be airplanes, fighter jets, bombers. If we cut back on all that, even aircraft carriers, shooting those long-range missiles and the intercontinental ballistic missiles, we could cut back on all that. We'll cut back on CO2. Yes, the Pineapple Express, we talked about that. So we don't necessarily need carbon dioxide to breathe. We can inhale carbon dioxide and it won't initially suffocate us, but we can't, if we just have a tank of carbon dioxide and you're breathing it in, it's bad, it'll suffocate you. That's actually what happened on Apollo 13. If anybody's seen the movie with Tom Hanks, it was a great movie, but it was also based on real things. There's a way to filter out the carbon dioxide because you have CO2, 2 different chemicals, or 2 different elements. You pull the carbon out because the carbon bonds are pretty strong. Remove the carbon, you pull the carbon out of carbon dioxide. You're left with dioxide, which is O2, which is what we breathe. That's the oxygen in the air that we breathe, O2. So there is this rebreather method that they were using. It failed. So as you exhale, you're exhaling CO2. If these 3 men in Apollo 13, the 3 astronauts, they were using all the oxygen in the capsule, and they were producing so much carbon dioxide that they actually started to suffocate. So we don't need carbon dioxide to breathe. It would, if we were just in a carbon dioxide environment, it would kill us, which is almost what happened in Apollo 13. 3 astronauts on their way to the moon suffocate to death, and then who knows what would happen with the capsule. So they were able to correct it. They were able to jerry-rig something that reactivated that rebreather. That's kind of also how rebreathers happen with some type of scuba diving that you do. So scuba diving, you typically think you have the big air tank, not an oxygen tank, because if you breathe 100% oxygen in, that's bad. Not sure if that's what you're thinking. So if we remove all the carbon dioxide from the air, this is maybe what you're referring to. What was it? His striker? So if this may be what you're referring to. If we remove all the carbon dioxide out of the air, it would still be bad. Not for us, but for plants. Plants would suffocate because they need carbon dioxide to essentially breathe. And if plants suffocate and stop breathing, then they don't produce oxygen. And if they stop producing oxygen, we don't have the oxygen to breathe. That's where we need carbon dioxide for the plants, not for us. Carbon dioxide lets them breathe, and they exhale oxygen that we inhale. We exhale carbon dioxide that they inhale, and it's this whole cycle back and forth. So that is where we need the carbon dioxide. So we need to reduce the amount of carbon dioxide out there, because carbon dioxide is the main greenhouse gas. By greenhouse gas, I mean it's a layer up in the atmosphere that you have the sun coming in. It has, say, ultraviolet rays that hits the earth, heats up the earth down there, and it radiates back out infrared light. So carbon dioxide absorbs infrared light. So it'll hit, once you have this infrared heat coming out of the earth, hits that carbon dioxide layer, and either will just be absorbed and stay there, or actually gets reflected back down. That's where plant greenhouses happen. You have sunlight coming in, it heats up things in there, and then the heat tries to escape, but you have that layer that is the greenhouse, and that prevents the heat from escaping. That would be interesting. I don't know. I don't want to name any specific planets, but if there is a different planet out there and it does have oxygen, because oxygen is universal. The periodic table of elements happens everywhere in the universe. Even if Thanos is trying to wipe out half the universe, you're still going to have these natural elemental things out there, which oxygen is one of them. So maybe there are other light, and this is actually going back to another, I forgot who it was in the very beginning with the comments. They were saying, asked alien races maybe visit us. If there are alien races out there and they're similar to us, maybe they breathe oxygen like us. But that also has to do with us in war. We're adapting war for the climate. We have to adapt ourselves for our climate. So maybe over eons, alien races, they adapted to breathe a different element. And they have a different process that they get energy from. Maybe it's possible that those other elements are on there. Thanos breathes whatever he is on. Oh, interestingly enough, I don't know if I have it here. So, on television with the Fios, I actually made a drawing. Let's see if I can just pull it up real quick here. Here it is. Let me see if I can send it over. I don't know if it's going to work. Okay, it did work in this account. Let's see. There we go. You can switch to the computer screen there. That's my drawing. That was part of a graphic I made with Fios. It basically had Thanos saying, "I'll see you very soon." So, interesting. It was the first time I really got nitty-gritty with a drawing. This is what's great with working with creative people and very artistic and skilled. Also, I had to do a lot of research on these infinity stones. You know, that's orange and that's the red one. They look close in this view here, but I had no idea what the order was for all of the infinity stones. So that was something I had to actually learn. All right, we can switch back to the main camera now. He's not breathing O2. Maybe he's breathing, because maybe he's just breathing nitrogen, because nitrogen kind of has this blue tint. Let me see, where's the mouse? I lost my mouse. There it is. I just want to see if nitrogen, what color bluish or purple is. Because when you burn different elements, they actually have different colors. For instance, when you burn sodium, it's, oh, interesting. These are, so this is talking about salts. Let me switch, let me get this here. All right, we put up the computer screen. So this has to do with salts. So chromium hydroxide is green. This is an interesting one, this blue, this copper sulfate pentahydrate. Oh wow, this is taking me way back to high school or college chemistry. Deep blue. That's kind of a Thanos-y color. Cobalt 2 chloride hexahydrate. Huh, some funny names there. Let's see. Ions in flame. Potassium. Lilac violet. There we go. So maybe there's potassium gas that he's actually breathing. What is this? Rubidium. Pink red. I think this is closer to it. Potassium, which is also something that's fairly common in the universe. Potassium. And that's kind of what potassium looks like. Which is, potassium is actually a metal. All right, we can switch back to the main camera. So, interesting question. Thank you for that. Let me see if I can back that up. He may be sniffing it. Interesting. But, yeah, that lilac purple color was potassium. Now, salt that we have is sodium chloride. It has sodium and chlorine. Sodium and potassium are actually in the same group. So you can have potassium chloride. So maybe potassium is a bit more relevant there, because when you burn potassium, it's purple, the Thanos-y color. And I just want to double check with this. Where's the mouse? There's, excuse me. Where is it? And cobalt. Cobalt chloride. Deep magenta. Interesting. So maybe different salts that we have can have a couple different things. different parts of the universe. You never know. All right, we can switch back to... Oh, I locked it again. I have a quick thing for a lock. Where are your comments? Here. Thanos eats too many bananas. He looks like kind of a purple gorilla. That big, bulky side. A couple of my friends actually that went to the premiere, these premieres had life-size replicas of Thanos, which I thought were quite interesting. And the life-size replica of Thanos was bigger than I thought. It was one of my friends took a picture of with this life-size replica. I know the size she is. And then I saw Thanos and I was like, wow, he's big. Now, I don't know a lot going into Marvel, but I don't know what the original size of Hulk was. But going into the TV show with the wrestler that played Hulk, not too much bigger than a standard human. Then the size of Hulk really got bigger over the years, and especially into movies. But I don't know if Thanos and Hulk are actually the same size in movies and comics. But interesting. And then really going deep into the Marvel Cinematic Universe, the MCU, I didn't realize how Thanos is connected through the whole thing. And there were a lot of little like subplots going on with the comic books, which all those comic books and all those volumes obviously can't happen in every single movie. But interesting to read. I know there's some comic book buffs out there that I work with, and they feel like they know this like the back of their hand. But Thanos eating too many bananas. Interesting. I don't know what he would do if he just has nothing to do. Which I think was another weird thing where he became a farmer. Some odd thing. There was another odd thing where Thanos had a helicopter. Seems weird you have this big badass Thanos just flying around in a helicopter. I forgot what comic that was, but there was some weird... It was also, I guess, going into generations. The generation of comics then was a bit more lighthearted versus the same studio, Marvel, going into movies and even some comics that are coming out now. It feels darker. And this, I guess, has to tie back into war. War is, I guess, more prevalent now, and a lot more people are familiar with it. And movies are kind of a reflection of our current species and current generation. Kind of an interesting thought with that. So we don't got too much time left. Maybe another, 5 or 10 minutes at most. But the last little bit was basically just general discussions. I always like to save general discussions for the end. So if you have any questions about the topic that we talked about, which was war and weather and this whole conspiracy theory with HAARP and how it actually could control the weather, yeah, let's talk about that. Otherwise, I was actually talking with somebody here about, I was building a gaming rig, or I built a gaming rig 2 years ago, and I was on the process of upgrading it. And upgrading to, essentially I was doing dual graphics cards and SLI, it's called, which is Scalable Link Interface. It allows 2 graphics cards to output one game. And it increases because instead of having one graphics card do one frame at a time, you have both of them rendering frames. You have this one rendering out a frame, and then by the time that frame actually goes, this graphics card rendered it already and sent it out. And by the time that graphics card sends out that other frame, the other graphics card is rendered the next frame. So that's where you get this scaling and this, not really full doubling, but an increase in frames. And with computers, nothing always goes as planned. So in my gaming rig, I know, say what you want, I have Wi-Fi in there versus Ethernet, which you should have Ethernet for a gaming rig anyway when you're playing online games. But I have Wi-Fi in there. And with the processor, They have PCI Express, has a certain limit of lanes. The processor I had, which was a 6700K, had 16 lanes. So if you have a single graphics card in there and that's it, then you have 16 lanes being used. All the lanes are being used. You put another, say, Wi-Fi card in there that was using 4. So 16 minus 4 gives you 12. So I had 12 lanes dedicated to the graphics card and 4 to the Wi-Fi card. That was fine. Dropping that from 16 to 12 doesn't affect graphics performance because the ports are not, or the bandwidth isn't saturated. Then I added the second graphics card. And when that happens, each graphics card is running at 8. 8 gives you 16. And that is fine, even though it's half, 8 lanes versus 16 lanes. It still is fine. You don't really see that much of a performance drop. And then you link the cards together with a special bridge, and it just negates any kind of performance loss. I still had a Wi-Fi card in there, and I didn't think about this before I actually installed it. So 16 lanes total. I had 2 graphics cards and the Wi-Fi card. So one was running at 8, the other one actually dropped to 4, and then the Wi-Fi card was 4. So 4 gives you 8, 8 plus 8, which was the top card, 16. That was the theoretical maximum. So to get this SLI working, you can't have less than 8. So if one was at 4 and one was at 8, it just won't turn on. So I had to remove the Wi-Fi card, then I had to run some Ethernet down my house and get that going. Oh, weird thing, temporarily I was actually using the computer here to have Ethernet connected from the gaming rig into my laptop, and then the Wi-Fi from the laptop to the router. It's a weird thing I'm going right now until I finish running the Ethernet. But that was, removing that, fine. Then I had the 2 cards, each at 8, giving 16, and that worked. Then, still didn't turn on. My motherboard specifically needed the graphics card in slot 1 and 3. I had it in slot 1 and 4 because I wanted a little bit more space there to get airflow. I had a bridge that matched that. Didn't work too easily. When I moved it down to slot 4, it was actually running at 4. So I wasn't using all the PCI Express lanes. I had 8 and I had 4. So I had to move that back up, and then when I did that, the bridge didn't fit. So I had to grab an old bridge and connect them. Then it finally turned on. I was able to activate and enable this SLI. So I went through quite a bit of troubles. If anybody here actually follows me on YouTube, Sunday night, fairly late, what was it? I think I started at like 9:50 at night, and I went for about an hour and a half-ish. I did the whole build. And another issue I ran into was the 2 graphics cards each had 2 power connectors. I had 3, so I had to upgrade the power supply, and then I went through the whole hour and a half of going through that. So that was pretty much my struggles over the past couple of days. I got SLI going, and that was pretty good. So it looks like 30 minutes? What was that? Sunday late night stream. 30 minutes. Yeah, let me just double check. It was, we'll be wrapping up in a few minutes, it looks like. And actually, don't forget to stick around after my show, because we have a fairly regular show coming on. It's the Snapchat show. I forgot the two names. They're nice people. Basically, it's Snapchatting through high school. That's kind of what their show is on. I am 10 years outside of high school. I'm almost 30 years old, so I can't believe I actually said that. It's weird just getting up there in age, but going through high school when I was in high school compared to high school now seems very different. Snapchat didn't even exist. But what was I doing? Oh yeah. I was just checking on my YouTube channel just to see. It actually shows the length of the streams. Actually, let me switch. So, don't worry there, I just disconnected the screens. So let me just double check here. I think it was like an hour and a half. YouTube Creator Studio. There we go. Live gaming rig upgrade. This is an hour and 24 minutes. I didn't even realize it was that. So an hour and 24 minutes. That's what I did. Where's the chat? There's the chat. Yes, Sylvie and Liam. They're the ones that usually come on after me. He is an epic gamer. The main game I like playing now is Doom. Doom 2016, which before I wasn't really getting the frame rates that I needed, because now I upgraded to 4K gaming. And with 4K gaming, you need a high-end graphics card. I had a GTX 1080, so now I have SLI GTX 1080s. And they ended up coming together very nicely now. It was a bit of a struggle, but we got it. Fortnite, I do not play. I have been recommended to play that. PUBG and Fortnite were both games that I was told I should get into, but I haven't really yet. Yes, I do have dual 1080s. For the 4K, almost 120 hertz. That was my goal. 4K takes a lot itself, and getting high frame rates over 60 frames per second at 4K needs a lot. The single GTX 1080 in Doom, I was able to get maybe 70 to 80. It wasn't up to 120. It was a thing I'm trying to do with a friend where we're trying to get a 4K 120 hertz screen. It'll be coming. We'll try and get there. Huh. You didn't actually ask, can it run Crysis though? Running Crysis is, especially Crysis 3, that's the one that we typically go for as the benchmark. Even though Crysis 3 is quite an old game, it's a very demanding game, and it's a game that I still use as a benchmark. And I have not tried Arc on Max. So, I guess I'll try that. Alright, so that's pretty much it. Unless anybody had any last minute questions, we'll cut the show early so we can get ready for the next show with Sylvia and Liam. Or Sylvia and Liam. Have you tried... I'm not sure what Hawking is, so I haven't tried it since I don't know what it is. Can it run Minesweeper at 60? No, nothing can run Minesweeper at 60. Or even Minecraft at 60. Overclocking, I do have mine overclocked. It's a 6700K overclocked from 4 gigahertz to 4.6, so a 600 plus megahertz overclock. All right, well, thank you all for joining. I really appreciate that. I hope you enjoyed the show today. If you want to follow up next week, we always talk a little bit more about this war and weather, because war is not really the most upbeat thing, but war and weather is tied together, and especially with climate change. So, again, thank you all for joining. Stay tuned for coming up next with Snap with Sylvie and Liam. So, thank you, and I'll see you guys in the next episode of Climate Matters next week. Have a terrific evening.